Hi everyone, welcome to the Digital Hub Insights course on common financial functions in Python. My name is Cordell Tanney. I'm Managing Director of Digital Hub, and I will be your guide as we go through some of the most common functions that you are going to need to use repeatedly throughout your career, throughout all of our courses, anything really that you need to do in quantitative finance, all of your projects, there will be certain functions and calculations that you're going to need to do over and over. So we're going to go through them now because there's no point in you rewriting these functions every single time you have to do a new project. So our goal here really is to get you to understand the theory behind some of these main functions, and then we're going to code them out. What we really want to get done here is that you create a .py file, a Python script file that you could then import to any project that you do in the future, whether you do it through your own IDE like PyCharm or VS Code, or whether you do it on Google Colab. You will have this .py file with all of these functions, and you will be able to just import them and use them over and over again. We do make this .py file available inside the Digital Hub course platform, so you can always download it there, and we continuously add to this .py file. The more we go through courses, the more courses we launch, the more we're going to add to this file. So it is something you're going to want to keep coming back to, and right now, whether you do it yourself or just grab ours, that's entirely up to you. However, I strongly recommend that you understand the code behind all of these functions, because it is something that you will be doing over and over again throughout your quantitative finance journey. So that said, what are our objectives here? Like I said, understand the basic calculations. Okay? I want you to get an understanding for the theory. Then we're going to create that Python notebook. We're going to store everything in that notebook, and then we're going to download it as a .py file, that you could then use throughout the rest of our courses and all of your future projects. I hope that works for everyone. Let's get started. So the most important thing that you're going to have to do is retrieve asset prices. And this is something that you're going to have to do over and over again. Now, throughout this course and most of our future courses, we will be using OpenBB. So if you haven't gone through some of the other lectures and courses that we have about how to use OpenBB, please do so. We will show the functions here, but the main thing is we will be using OpenBB, and through OpenBB, we'll get the majority of our information, at least asset pricing, through Yahoo Finance. But as we go through the coding lecture, you will see that there is the opportunity to choose your own data provider through OpenBB. But for now, we're going to be sticking with OpenBB and Yahoo Finance to retrieve the asset prices. Now, the key thing is you might not always be working with daily data. And whenever you pull things in through OpenBB or Yahoo Finance, you need to be able to manipulate the prices so that you could have them in different time frames and different frequencies. Now, you might be asking at this point, okay, I get it, but why do we want to code this stuff when all of these functions are already written for us elsewhere in other packages or in other things that you might have done? And the answer is this. I'm going to show you a way to do it to make it so flexible that with one function you could do so much, because the goal of this is really for you to be so proficient and quick with what you need to do that one function can accomplish what you could be doing right now in 5 or needing 5 different Python packages. I'm going to show you how to get everything done once so that you could have it in the future and it's flexible to meet your needs. That's really the goal here. So once we have the prices, then we need to convert prices to returns. So much of what you're going to be doing in quantitative finance, especially when you start doing investment analysis or asset class analysis, portfolio optimization, we will be working with asset class returns. So you need to learn how to do all the calculations to calculate the returns. So the other thing that we need to do here, again, similar to what we have with the prices, is get used to doing this at different frequencies. Daily, weekly, monthly, quarterly, yearly. You need to be proficient to be able to calculate the returns at different frequencies. All right, it's something that you're going to have to do over and over again. Once we have our returns, it can be used, right? We can take this data frame of returns and then supply the returns data frame to all of the other functions that we are going to use throughout this course, multiple courses, right? So it is like the base data frame that you can use for asset class or investment analysis, or even machine learning algorithms, which we're going to cover in other courses. So learning how to calculate the returns is huge. It's the foundation. All right, so what are the functions that we are going to be doing then throughout this lecture, the initial one to get into our .py file, that are going to be based on returns? Okay, so the first thing that we're going to learn how to do is create a compound growth index. A compound growth index converts the returns to an index. So in other words, you would start at 100 and then 101 would reflect a 1% return on the next period. By converting things to an index, we can calculate period returns, or we can create graphs based on it. And I'll show you an example of that in a minute. But the most important thing here is by creating this growth index, and hence the name a compound growth index, it ensures compounding of returns, because that is key, because as you should know, based on investing, compounding is so important. And when you're creating multi-period returns, they must be compounded. And by doing it as a growth index, it ensures the compounding. So just to give you an example of what you can do with with a compound growth index, let's say you started the growth index at 1,000, you can just calculate what the growth of $1,000 would be, and that's an example of a compound growth index. So here you can see the 8 asset classes that we will be working with throughout this course and throughout the coding lecture. You can see the growth of them starting at $1,000. So you can see here the best performing one is the S&P 500, denoted SPY, which is close to $5,000. So your 1,000 turned into 5,000. And this is simply just by plotting out a compound growth index. So it's a key function that we have to build, and I'll show you why it's so important and how it's going to feed things like the returns. So what you're seeing here are the trailing returns. So this is another thing that you can do with the compound growth index or the returns, is figure out for each of our investments, what did it do over 1 month, 3 months, 6 months, year to date, and all the way through to since inception. You could really customize the time periods you want. And it's based on a specific end date. So it would be as of March 31st, 2024, for example. So the specifying the end date is huge, because then your function needs to be able to calculate the performance over these different periods as of an end date. So a function that can do this needs to be flexible to change the end date so that you can quickly reproduce these tables based on any end date you want. And we do it because, as you can see here, you can compare different investments over different time periods and see which one was the best over, 1 month, 1 year, whatever. And you can also set this function up to be so flexible that you can either produce the returns as a cumulative, which is the table on the bottom, or annualized. And what you'll see here, like just take an example of the SPY, since inception, which I believe in this case we're looking at since the mid-2012 or end of 2012, the S&P 500 is up a cumulative 378%, which is the same thing as saying 13.83% a year. That's an average return. So an average 13.83% return per year equates to a 380% cumulative return. So the function should be flexible to accommodate cumulative or annualized. And again, this is starting to hopefully highlight why this stuff is so important. Because by coding this out now, you're going to have flexibility as opposed to relying on previously, the Python packages you were previously using, which were pretty much hard-coded, and you're not going to be able to necessarily customize it according to your needs without having to do many more steps. So then we also have calendar returns. Calendar returns, just as the name implies, we're just looking, okay, what was the return in 2024, 2023? So it's just a quick way to visualize performance for an actual calendar year. Other functions that we need to do it's really, how do you annualize returns and how do you annualize volatility? This is something that's going to come up a lot, especially when you start doing portfolio optimization. So the actual, return, period return for any investment is just the ending value divided by beginning value minus 1. Of course, it gets a little bit more complicated if there were dividends involved in the period, but we're not dealing with that right now. It's just ending value divided by beginning value minus 1. All right, and that'll keep the return in decimal form, meaning 1% return would look like 0.01. So, but that sometimes, let's say that was over 1.25 years, 1 year and 3 months. You need to turn that into an average annualized return. So any period greater than 1 year, you might want to annualize, which is what we saw in the previous table with the trailing returns. So you need to be able to do this. This is something when it comes to annualizing returns, and yeah, the formula looks a little dry, but I wrote it out here exactly as we need to code it out. This is something that you need to be able to do. And to just know that, okay, what we're going to do is just take our period return, that's the EV divided by BV minus 1, that's what we have on top. We add 1 to it, and then we raise it or exponentiate it to 1 divided by this number of days over 252. So you need to know this. This is something that you should be able to do in Excel or be able to do in Python immediately. And to know that to annualize daily data, it is 252. Annualize monthly data, you're going to divide by 12. My question to you right now, think about it. What do you think the number would be for quarterly data? Now, if we're going to annualize standard deviation, in this case, we have to multiply the standard deviation, which we normally denote as sigma. We take the standard deviation of daily returns and then multiply it by the square root of the annualization factor. So for daily data, 252. For monthly data, it is 12. So again, this is something you need to know how to do in your sleep. You need to know how to annualize ratios, how to annualize returns, volatility on the spot. All right, that's something it's like a base thing that you guys everyone here needs to know. So we're also going to look at the maximum drawdown. So a maximum drawdown, the reason why I'm doing it here is because it is something that's going to come up repeatedly throughout investment analysis, portfolio analysis, asset class optimization, that kind of stuff. It's going to come up quite a bit. So a drawdown is defined as a peak to trough decline. So in other words, your investment hits a peak and then it just starts going down. And then you want to know very often, what was the worst drawdown? So why? Because it's a risk measure. It gives us an idea of how much you could lose in a worst case scenario. So whether it was going through 2020 COVID period or maybe 2022 or 2008, a lot of these are typically the worst case scenarios that we've seen. What was the worst performance seen from a peak value all the way till it hit a bottom and then started recovering again? Okay, so the issue with it, of course, it's being based on historical data, which may or may not repeat itself, but not the point. This is something that we use all the time in investment analysis, is a maximum drawdown. So it's something that you need to be able to do. We're going to give the function for it. So, and as you can see here, based on the asset classes that we're going to look at first, this tells you what the worst performance from a peak to a trough was. And you can see that some of the bond funds here, the IBND, which is an international corporate bond fund, iGov International Treasuries, have worse maximum drawdowns than the S&P 500. So I believe you can start seeing how this could be useful in investment analysis. And I'm going to teach you all about this in future courses. Okay, and of course we would expect riskier asset classes and investments to have a greater maximum drawdown. I guess how we define risk is really what matters. Okay, now the last thing we're going to cover is the Sharpe ratio. So the Sharpe ratio, it's a way of saying how much return are you getting per unit of risk. It's a risk adjusted return. Now the best way I like to explain the Sharpe ratio, because you want to be rewarded for taking risk, and in theory the more risk you take, the more you should be rewarded for it. So the Sharpe ratio allows us to compare investments that, let's say you want to compare a fixed income and an equity. That's like apples to orange. But if we wanted to do an apples to apples comparison about how well you were rewarded for the risk that you took, that's what the Sharpe ratio does. Think of two cars going down a highway. You have a Porsche and a Pinto. How are you going to compare them? We normally use speed, kilometers per hour. And that's exactly what the Sharpe ratio is doing. Instead of kilometers per hour, it's return per unit of risk. So we always do this, though, by taking the excess return, meaning we take the return of your asset or your portfolio and we subtract out the risk-free rate, which is really the return on cash. And then our unit of risk is standard deviation. So you might hear the words volatility or standard deviation. They're used interchangeably. Risk is typically denoted by volatility, which is the same thing as standard deviation. So higher is better. The higher your Sharpe ratio means the higher the return was for the amount of risk that you took. So this is the basic formula for it. It's the return of the portfolio, the average return of the portfolio. So I'm going to go through this in the coding lecture. The average return of the portfolio, let's say, subtract the average return of risk-free rate, and then divide it by the standard deviation of the portfolio. And then you will have to annualize the ratio. But we're going to look at that after. It's just important to understand right now, it is return, or we'll say excess return, divided by risk. That's the Sharpe ratio. It is one of the most foundational ratios used in investment analysis. It's going to come up all over the place, and I'm pretty sure by this point, if you've done your CFA, if you've done the FDP, if you've done any of the other designations out there, and you probably have, and you've come here for reinforcement of material and to just get better at what you learned, and hopefully at the same time want to learn from my 25 years of experience, that's what is going to be poured into these courses. So you're going to see the Sharpe ratio quite a bit. You're probably familiar with it already. All right, with that, I'm going to close out this lecture, and we're going to move over to the Colab notebook now, and we're going to code all of this out. Thank you.